Dear students, in vectors we have discussed the basic concepts, basic things related to collinear and coplanar. Now, in this exercise 8.2, coplanar vectors, in the previous problem we discussed only with vectors, but this one we are dealing with position vectors of 4 different points. Remember that previous one was 3 vectors, simply it is given, but now it is not given as such, as a vector. Position vectors of 4 different points. Remember, 4 different points means how to bring it to the normal position now. Now, here let us recap. Suppose if the position vectors are given 4 vectors. See, the position vector is O, represent anywhere like this: O, O to A, O to B, O to C, O to D, like that 4 vectors in a plane, pipeline, in a pipeline. Pipeline means you take your notebook, your ordinary size notebooks. So, that is a plane. In that plane there are 3 different points that we locate. See, like this is a plane. What we have the problem is, this is a plane, this is called pipeline. This pipeline we are taking, this is nothing but pipeline. In this we are representing a vectors. In what way? I am representing that as A, B, C and D. So, O to A as one vector, that is A vector, remember, and O to B, that is second vector, O to C as third vector and O to D as fourth vector. So, we are representing now 4 vectors in different contexts here. So, we are finding out AC vector, and for that we have to take, it is a coplanar. Coplanar means what? So, just we have, is a linear combination of x and y, linear combination of x and y. That means x of AB vector plus y of AD vector is equal to the resultant vector, call it as AC vector. So, now I am representing AB vector, AC vector and AD vector, or 3 vectors. So, AB vector is what here? This is first one is AB vector, second one is AC and third one is AD. How to calculate AB, AC, AD? We know position vectors. AB vector means second vector, OB vector minus OA vector. Likewise, AC vector means OC vector minus OA vector, and AD vector means OD vector minus OA vector. Like that, we have to first get the proper vector for this one, then we have to go to the problem side. Now, let us think about this problem in a simple way. So, here what is the representation is given? It is a position vectors, remember that, position vectors. So, let me take, let OA vector, O be the point of position vectors. OA vector is 4i plus 5j plus k vector, and for OB vector let me take 0i vector minus j vector minus k vector, and OC vector is 3i plus 9j plus 4k, and OD vector is nothing but minus negative 4i, 4j plus 4k. These are the 4 representation of vectors. Now, OA, OB, OC, OD. As I told you, if we want to prove these 4 vectors are to be coplanar, I should find out AB, AC and then AD. What is AB? So, that means AB is, as you know, OB minus OA. OB minus OA. This minus that. OB is what here? So, for OI minus j minus k minus of this, that is 4i plus 5j plus k, by which it is negative 4i minus 1 minus 5 minus 6j minus 1 minus 1 minus 2k, that is the first vector, that is AB vector. And for AC vector, likewise I can represent OC minus OA here. For each one we have taken the OA as the second vector here. So now let me directly consider subtract 3 minus 4 minus I here, 9 minus 5 minus plus 4j, and 4 minus 1 it is plus 3k. So we are representing AC here. And for AD, likewise we take AD2, that is OD vector minus OA vector. So first of all we have considered AB, I have done every steps, and for AC directly I have enumerated OC as well OA, and for OD, AD vector OD minus OA, everything we are calculating with the help of OA. So minus 4 minus 8I plus 4 minus 5 minus j plus 4 plus minus 1 plus 3k. So we have 3 sets of vectors, 1, 2 and then 3 here. So AB, AD, AC, AD. Now 3 vectors we have. Now we have to represent with the help of this formula. So to show AB, AC and AD are coplanar, we have to take the accountability of vectors. AC vectors equal to x into AB plus y into AD. So I drew the diagram. With the help of this diagram, very well you can calculate, you can get this idea in a simple way, simple manner. So let us take what is AC here. So you take this second vector, that is minus I plus 4j plus 3k, and x into AB, what we call, that is y into AD, that is minus 8I, AB I am sorry, minus 4I minus 6j, then minus 2k, then plus y into AC vector, AD vector, this is AC, AC is this minus I plus 4j plus 3k, x into AB vector is this part, and for AD minus 8I minus j then plus 3k. So now we have the vector like this. So equating like that corresponding components, like equating like components, like components of ijk, I, j, k on both sides. So like components means we have to equate either side. Here I is nothing but minus 1, and here it is negative 4x, and here it is negative 8y, that is equation A you take. And solving this fourth one, 4 is equal to negative 4x 6x, then negative y, that is equation B. Next one, let us take k, 3 is equal to minus 2x, then y into this 3y. Now equating like components of x, I, j, k of either side, here minus 1 minus 4x and minus 8y, and 4 means minus 6x minus y, and for k it is 3 is equal to minus 2x plus 3y. You can solve any one of this with the help of cross multiplication, rule of cross multiplication. By applying it, you should get the value of xy, and that xy you take into consideration into third, and you have to just substitute and you have to arrive the value of 3. That means it is coplanar. If it is not satisfied, it is not coplanar. It is clear to you. See what else you should do when you are solving these two equations. You are going to get the value of x and y. After calculating x and y, you have to substitute in the third equation, so called C. So here when you substitute x and y, you have to arrive the value of 3. If you arrive 3, what we have taken the equation, what we have considered as a coplanar, it is right. If you are not getting, it is not a coplanar. But according to this problem, it is clearly it is clearly given it is a coplanar vector. So what we have to do, only thing we have to prove the value of x and y. Let us start by rule of cross multiplication. By the rule of cross multiplication, any method you can solve it. You know so many process of x and y. Here I am taking x, y, 1 and then x. Here minus 4 and then minus 8, then plus 1, because I brought to one side. Then again it is minus 4 and minus 6 and then minus 1 here and then minus 4. Once again we repeat the value of x. Now let us take x is equal to, leaving this part, in the next two columns we have to consider next 8, 1, minus 1, minus 4 of determinant is equal to y by what we have here, y is equal to next two columns 1 minus 4, then minus 4 minus 6. Then for 1 here, first two columns negative 4, negative 8, then negative 6, negative 1. So I repeat, x is equal to negative 8 plus 1, negative 1, negative 4, y the next two columns, and for 1 the first two columns. Like that I have taken. Next part I should just recall, x is what, y is what, and 1 is what. I should write down all those values now. X is what, minus into minus plus, it is 32. Then 1 minus is there, obviously it is plus 1. Y divided by determinant of 1 minus 4 minus 4 minus 6. So negative 6, negative 16, negative 6, minus into minus plus, again minus, it is 16. And the other one, it is 1 plus 4 and negative into negative positive, once again it is minus. So 6 8s are 48. I could recall. So plus 4 and then minus 48. So now x by 33 here, y by negative 22 and 1 by negative 44. Likewise I got the value of x, y and then constant. After that we have to compare 1 and 3, 2 and 3. X is equal to 33 by negative 44. We have to divide it, both are cancelled by 11. So here it is 3 and here it is 4, negative 3 by 4, and y is equal to negative 22 by negative 44, which means it is 2 by 4. So here 11 and here it is 4, again it is divided by 1 by 2, that means 1 by 2. So y is equal to 1 by 2 and then x is equal to negative 3 by 4. So we found out two values of x and y. So we have just from this x is equal to negative 3 by 4, y is equal to 1 by 2, we found out two values of x and y. This we have to carry out to the third equation of minus 2x plus 3y, which we have to arrive as 3. Let us check whether it is a coplanar or not. To check x and y in equation C. In equation C, let us take negative 2x plus 3y, which means negative 2 into x. X is what? Negative 3 by 4 plus 3 into y. 3 into y. Y is what? We have it is 1 by 2. So let us take these two equations now. It is 6, these two getting cancelled, it is plus 3 by 2, plus 3 by 2, which means it is 6 by 2, which means it is 3. So finally we have arrived the right hand side part, RHS. So what we have, the third equation, minus 2x plus 3y is equal to 3. We have taken LHS of third equation, LHS of C, that we have taken as minus 2x plus 3y, and finally after substituting the value of x and y into this, we finally arrived the 3. That means all the 3 vectors, that is OA vector, OB vector, OC vector and OD vector are, hence we have to conclude the result. That is very, very important. So it's a coplanar vectors. By seeing this, we have proved that OA, OB, OC and OD are coplanar vectors. Let us recap all that. So show that the point whose position vectors are coplanar. That means we have to take the fundamental rule of AC vectors equal to x into AB plus y into AD. By taking this, I have taken OA, OB, OC and OD are 4 different vectors, and AB second vector minus first vector. Likewise, I have solved AB, AC, AD. I found out 3 results, and I have taken the fundamental rule of coplanar vectors of AB, AC, AD. AC vectors equal to x into AB plus y into AD. So by way of taking this, equating like components, we are arriving 3 equations. Of taking all the 3, you take any 2 equations and solve the value of x and y, by which I have found out x as minus 3 by 4, y as 1 by 2. By taking this x and y to the third equation, I have arrived the value of 3. So that means all the 4 vectors are coplanar vectors, which comprising this problem is correct. So that means OA, OB, OC and OD are coplanar vectors. With this problem is solved.